Huntington's disease, a slow death of the brain, with no cure to be found. 17 to 20 years to live. This disease caused by mutation to the HTT gene is extremely rare, but can be very life-changing. The gene HTT makes a protein known as Huntington. The exact function of this protein is unknown, but it does happen to play many roles regarding nerve cells or neurons in our brains. Without this protein, normal development before birth would be way out of reach. Huntington is found in many body tissues, but remains most prevalent in the brain. It consists of many of the following functions within our cells. Huntington's disease affects families through an autosomal dominant pattern, meaning an affected person usually inherits the defective gene from one parent. The size of the CAG trinucleotide repeat increases in size generation after generation. A mutation to the HTT gene is caused by repeat expansion within the nucleotides of a DNA code. It is known as a CAG trinucleotide repeat expansion, thus obviously increasing the size of the CAG segment in each HTT gene. The CAG segment is repeated 10 to 35 times within a normal gene. 36 to 39 repeats lead to a disease with no display of symptoms. However, in order to be affected harmfully by this mutation, this nucleotide has to be repeated 40 plus times. During replication, it is possible for the polymerase to slip from the template strand. This can cause the new complementary DNA strand to unpair from the template. If the slip happens at the codon repeat region of the Huntington gene, the loose strand will have many identical codon copies to reattach to. A bubble of unpaired bases may be formed, which is the expansion of the new strand. Another common cause of the expansion is due to alleles switching places between chromosomes during meiosis. However, it is possible for this crossing over to occur unequally, only switching over certain segments of the alleles. After crossing over, one chromosome will have a Huntington allele with more CAGs than before. This minuscule molecular change to one gene causes the disease we know today, known as Huntington's. The expanded CAG segment in HD patients lead to the production of an abnormally long version of the Huntington protein. The larger protein is cleaved to produce a shorter N-terminal fragment containing the polyglutamine expansion, thus causing the protein fragment to misfold and accumulate in neurons as they bind together. Once the folds, or otherwise known as aggregates, are formed, ubiquitin tags mutant Huntington for degradation. The proteasomes are then inhibited by Huntington aggregates, and the aggregates continue to accumulate. Neurotoxicity is later caused by the misfolded protein present in its soluble form or in aggregates. This process affects the regions of our brains that help us to control thinking as well as coordinate movements. These regions happen to consist of our striatum and cerebral cortex. Scientists have now been introduced to many potential mechanisms regarding neurotoxicity. This may include caspase activation, an inhibition of proteasome activity, and repression of transcriptional pathways. This molecular effect to our genes has a huge impact on one's ability to function, resulting in various disorders surrounding movement, cognitivity, and psychiatric health, some of which present phenotypic symptoms. However, most people diagnosed with Huntington's show symptoms within their 30s or 40s. Some common movement disorders include involuntary jerking, muscle rigidity, slow or abnormal eye movements, difficulty with the physical production of speech or swallowing, and finally, impaired walking, posture, and balance. There are also some observable mental symptoms, including a lack of impulse control, difficulty organizing or learning new information, as well as a lack of perseveration. To this day, it is known that mutagens do not seem to play a role in the development of Huntington's disease. However, HD sometimes rarely appears in a person whose family has never had a history of this disease. This is not due to the environment, but instead a genetic explanation. Huntington's disease is simply caused by a single mistake, but has the ability to change one's life forever.